we're going to start off with a little warm up that's going to help us kind of get in the mode to help us out with this. And we're going to do this by hand. So we've got a question here up at the top. Make sure you're looking at the side that has the warm up at the top. The two sides look very similar. Make sure you're on the side with the warm up at the top. And it says simplify using order of operations. Let's remind ourselves order of operations. Jot those down up here. Starts with a P. How's it go? PEMDAS. Thank you. Please excuse my dear Aunt Sally, or however you memorized it. So let's work through this. P stands for parentheses. I see some parentheses here. Now, is there anything actually happening inside of this parenthesis? Anything I need to simplify in there? Nope. What about this one? Nope. It's already a single number. I'd say parentheses are done. So we don't need to worry about that. E stands for exponents. I see an exponent that we got to do. So we're going to have this -3 to the second power. And we'll simplify that piece and bring the rest down. What is -3 squared? That would be whatever -3 times -3 is. +9. Okay, so that turns into a +9. Go ahead and bring down your negative, bring down your +6, and all the other stuff too. Okay, we're doing good so far. We're doing well so far. So we've taken care of exponents. Next up comes multiplication and division. We kind of do these both at the same time, left to right, top to bottom. I do see multiplication in here. I see 6 times that -3. So go ahead and do that. Write down your next step, bring everything else down. Thanks. Positive times a negative is -8 times, or sorry, 6 times 3 is 18. So we got our multiplication division done. And then we stick addition, subtraction together also. We just go from left to right. So this is just a whole bunch of subtractions. So -9 minus 18 would be -27. -5 would be -32 for our final answer. We feeling okay about order of operations? Good, because we get to do it all whole bunch in this problem. So our big goal for today is to translate from an equation to a graph and then a graph to a table. Equation to graph and graph to table. We did something very similar to this on Thursday last week. We went from a situation to, I'm sorry, I said that backwards. Equation to table and then table to graph. That's what we're doing today. On Thursday last week, we did situation to table and then table to graph. You guys remember on Thursday? We were counting beans and making hot tub tiles and all that stuff. Timing signatures, okay? This time we're working from an equation rather than a situation. So I'm gonna walk you through the first couple of these. We're gonna do the first couple of these by hand, and then we're gonna use our technology resources to make this go much faster. So I do want you to start with the first row here. We're going to be using this equation. Look under that piece of paper right there. We're going to use this equation, and this first one we're going to do by hand. Okay, so I would like you to recopy this expression with the x's, but leave all the x's out, and in their place, leave some blank parentheses. It should look just like this. Go ahead and write that down next to that first row there. And so we've taken our x's out. That's the same as this top equation here. I just left my x's out. What am I going to put in place of that x if we're working on that top row? -6. X is -6 in this first row of our table. So put a -6 in here and in here. And then I would like you to, without a calculator, please, to go ahead and simplify that. Same way we just did our warm-up problem. So let's start with the exponent here. What is -6 squared? -6 times -6 is positive, right? 36. Bring everything down. There's our exponent. We need to do our multiplication next. That would be this 6 times the negative 6. Positive 6 times negative 6 is negative 36 again. Bringing everything else down. All right, and this last step, if you need a calculator, that's okay. I think I can pull this off of my head. Negative 36 minus 36 is negative 72. Minus 5 would be negative 77. Can someone check it in the calculator, though, for me, please? Negative 77. Woo! And where are we going to put that in the table then? On the top row, right next to the negative 6. So we started by putting negative 6 into the equation. Our output was negative 77. And that goes in there. So it's kind of like we're putting stuff into the function machine. Except we have a whole bunch of things to put in there. We're not going to do all of these by hand. We're only going to do a couple. Then we'll turn around and do the rest with our calculators. Okay. So bear with me here. Any questions so far? All right, let's do negative 5. So start the same way we did just a second ago. Rewrite the equation, but leave out all the x's. What are we putting in place of our x's this time? Negative 5. Put them in both parentheses. Let's go, guys. Get caught up here. Do your order of operations. So the negative stays the same. What is negative 5 squared? Negative 5 times negative 5 is going to be positive 25. What comes next? We've got some multiplication to deal with in here. 6 times negative 5. Positive times a negative is going to be negative. What's 6 times 5? 30. So negative 30 there. Bring everything else down. And then we just need to combine all that together. Negative 25 minus 30 minus 5 is going to be negative, I believe that's negative 60, but I'd love if somebody could confirm that with a calculator. Is that what you're getting? Sweet. Okay, so if I ask you to evaluate for a particular value of x and I say show your work, and do it by hand and show all work, I need to see steps that look like that, okay? Now, I'm not going to ask you to do that a whole bunch, but I'd probably ask you to do it for 1 or 2 on our first test. And then for the rest of them, I'll say use your calculator. So we're going to switch over to doing this on the calculator. So if you got your calculator with you today, get it out. Otherwise, you're going to have to share the yellow ones that are dispersed throughout the rooms. I need to steal one of these. I'm going to take, oops, sorry. Can you put that underneath your desk, please? Thanks. Thank you, thank you. I hope I didn't break anything in there. Do you have any fragile things in there? Okay, good. Okay, just a second, please. Is this a right now type question? Sure. Hey guys, can you please stop the side chatter, please? Thank you. We're doing stuff as a class right now. So if you have an individual question, you'll need to save it for later. All right, we're gonna do for -4. Let's write it down first and then we'll type it into the calculator. All we need to do is write down the original thing. So same as before, negative x squared plus 6x minus 5, but this time we're putting a -4 in its place. And this time I'm not going to go through and do it by hand. I'm going to use the calculator. Now this gets a little tricky and I want everybody in here to have a chance to type this in and make sure you're getting the correct answer. Are you guys familiar with these types of calculators and how there's a difference between a minus and a negative? Are you guys familiar with that? Where's the minus on your calculator? The minus is on the side and the negative is down here. Now, when I type this in, the only thing that's going to get a minus is this 5. You only use the minus key if you have that symbol with a number immediately after it. Okay. Here, this is going to be a negative, this is going to be a negative, and this is a negative. So what I need all of you to do right now is to type this in. By the way, if you're looking for the square button, it's right here. The one that says x squared, that's what you're going to do to get your square. So I need everybody right now to type this in. Negative parentheses, negative 4 squared plus 6 parentheses, negative 4 minus 5. Type it in, hit enter, and you should be getting negative 45. If you do, hand it off to somebody who's sitting near you who has not yet typed it in so they can give it a try. I want to make sure that everybody's getting that answer. These calculators are a little tricky to use. Let's make sure everybody's comfortable using them. If you're getting an error, please let me know. Did you guys get negative 45? I did. You're going to have to share because I need one for the model at the front of the room. I'll give it back once we're done with our notes, okay? Were you guys both able to get negative 45? Can you try typing it in for me? Did you get negative 45? Okay, I need you to type in the step that we just did, which I've got up on the board there. Please type that in. Should look just like my screen there. Make sure you're getting negative 45. This gets a little tricky between the negatives and the minuses. Now would be a good time to ask your question. Oops, I didn't want to turn them off. Okay, does anybody having trouble getting that negative 45? Where are we going to put that in the table? Right next to negative 4, because that's what we put in. So put it in here. Now, I want to show you the biggest shortcut. This is going to save you literal minutes of your time, okay? When you've got to do one of these tables. You don't want to miss this. If I wanted to go and do negative 3, there's a shortcut. Actually, there's 2 shortcuts. Can someone tell me what I could do to just do nothing for negative 3 and just write down the answer? What is the answer going to be for negative 3? Did anybody notice that we already did this same thing for negative 3 in our warm-up? Isn't this work up here exactly what we would have done if we wanted to plug in negative 3? It's the same equation, isn't it? And we got negative 32. So, all right, so let's write it down. Now, we have not done negative 2 yet. Let's see if you guys know how to do this. There is a way that I can just go back and edit this and change these 4s into 2s without having to type everything back in again. Do you guys know how to do that? Different on your calculator, I think, than it is on mine. Yeah, you go to the arrows, you go up. So if you've got your calculator right now, watch this. Watch this. This is going to save you so much time. Go back up and highlight what you just typed in. I'm using my arrow key to go up and highlight it and hit enter. That's going to bring that back with the cursor, and then you can move over to those 4s and just type a 2 right over top of them. Then you don't have to type the whole thing in over again, right? Isn't that nice? Save you so much time. That gives us -21. All right, and then when I want to go and do -1 instead, I use the arrows to highlight that last thing, hit enter, and then I can just cursor over and write over those 2s with a 1. And that'll give me my next one. So what I'd like you all to do right now, I'm going to give you a couple minutes to do this, is fill out the rest of that table and then plot the points that you can. Most of these points are not going to fit on your graph, but plot the ones that you can, okay? So use your calculator to fill out the rest of your table and then plot those points. All right, I'll be around to answer questions. If you got any questions, if your calculator is giving you a hard time, let me know. All right. Once again, if you haven't checked and copied the correct values, get them down. Use a pencil next time. Just scratch them off and write the correct answer to the right. I only make 1 copy per student, okay? I have extras, but they're for the people that aren't here, okay? So just scratch them out. It's okay. You're not turning this in, so it'll be all right. And if you don't bring a pencil next time, remember I've got some in the drawer, but put that on the shopping list. Make sure you got pencils. Okay, we're going to graph these, and some of you graphed these already. Most of these aren't going to fit on our graph. When I look at my y values, my y only goes down to -10. So I'm not going to bother till I get to here because these are all too small. So let me get these graphed here. So -5, or sorry, 0, -5. So 0 on the x and -5 on the y would be here. 1, 0, 2, 3, 3, 4, 4, 3, 5, 0, 6, -5. We should have gotten points, those points there. And then we're going to connect those with a nice smooth line. Not a jagged line, but a nice smooth curve. And this graph would continue further down in both directions. So if you haven't already, go ahead and put some arrows down there to indicate that. Take a moment and graph that, and then we are going to come back and we're going to do some analysis. We're going to describe this graph. We got a list of stuff down in the lower left-hand corner of the graph. If you want to look at what we're going to be labeling on here, we're going to actually label these right on the graph. Before we get started on this, does anybody know the name of the family of graphs we're looking at? It starts with a P. I heard a couple of people saying it as I was walking around. I think you said it, didn't you? It is a parabola. Nice work. How many people have heard that word before? Parabola. Good. So if you need to write that down, it's also written up here. Parabola. That's the general shape of this thing. So if I were to ask you what shape it is, it's a parabola. And basically, we're going to get to the point where you're going to see a test question where I'm going to ask you to describe the graph. And you want to say as many things as you can about the graph. You're going to point for each of those things. So when you say a parabola, there's a point. You can also tell me which direction the parabola opens for another point. Anybody want to give me another point? Is it opening up, down, left, or right? It's opening downwards. So parabola opens down. If I can spell. Opens down. Most of our parabolas in this class are going to open up or down. And then the rest of the stuff that you can get points for at this point are listed off to the side. So the first one says line of symmetry. Does this graph have a line of symmetry? Is there a place you could fold this graph to get both sides of it to match up on top of themselves? You see, yeah. So go ahead and let's draw where that fold would be. I like to use a dashed line for my line of symmetry. Sketch that right on your graph, right all the way up through it. You guys have heard of symmetry before, right? Yeah. And I'm going to label that line of symmetry. That's enough to get you a point in this chapter. Now, when we get to chapter 2, I'm actually going to ask you for the equation of that line. Does anybody happen to know the equation of that line? I'm going to guess the answer is no, because it's chapter 2 of Algebra 1. I'll tell you what it is, but you're not responsible for knowing this right now. A vertical line is just going to be an equation that says x equals, and whatever number it's crossing the x-axis at, and in this case, it's what? X equals, what is the x-coordinate of every point on that line? What is the x-coordinate of every point on this dashed line here? What's the x-coordinate of this point? What's the x-coordinate of this point? And the x-coordinate of this point? All the points on this line have an x-coordinate of 3, don't they? So x equals 3. Now, you don't have to know that. I'm going to put parentheses around that because you do not need to know that. I do need you to know that that is the line of symmetry. And you got to be able to draw it. Are we good on that? All right, you guys are doing great. Let's do intercepts next. Intercepts are where they cross either the x-axis or the y-axis. Let's start with x-intercepts. How many x-intercepts do you see on this graph? 6. I don't see that many. 12. How many x-intercepts do you see? How many places do you see where this graph is crossing the x-axis? I see 2 x-intercepts. One's right here and one's right here. I'm going to write down x int up here, and I'm going to draw some arrows that go to those x-intercepts. And I'm also going to write down the names of those points. You guys know how to name points, right? Parentheses and a comma in between. You do an x-coordinate, then a y-coordinate. So we have 2 points, so we should have 2 names here. For this point right here, what is the x-coordinate of that point? What is the x-coordinate of that point? 1, and the y-coordinate is 0. So 1 comma 0, that's this point right here. Because on the x-axis it's at 1, and on the y-axis it's at 0. What about this one over here? What's its x-coordinate? 5, and then y-coordinate is 0. 5 comma 0. Agreed? All right. So those are x-intercepts. Do you see any y-intercepts? I see 1 y-intercept. Let's go ahead and label it. So its graph is crossing the y-axis right there, so that would be a y-intercept. And let's write down its coordinates. Now this is at -5. My question is it -5 comma 0 or is it 0 comma -5? 0 comma -5? The 0 comes first because that's the x value. The y value is -5. You're right. 0 comma -5 for our y-intercept. All right. What else we got on there? What have we not done yet? Vertex. Vertex. Not every graph does not have a vertex, but parabolas do. What is a special point on this graph, do you think, that we have not yet labeled? The one that's on the line of symmetry? Yeah, that is the vertex. This is the vertex. The vertex of a parabola is kind of the point where it turns around. All right, so that's our vertex there. So let's label it vertex. And let's write down its coordinates. 3 comma 4, did you say? You sure it's not 4 comma 3? X is 3, the y is 4. 3 comma 4 for a vertex. Okay. All we got left are maxes and mins. Maximum. A maximum would be the highest point on the graph. Does this graph have a highest point? Oh, the vertex is the highest point, isn't it? Yep. So this is also the max. Now, if I want credit, we're going to label it as max, and we'll write down that 3 comma 4 again. Draw some arrows there. All right, if the max is 3 comma 4, then what is the min? This is a trick question. 0 comma 5. I heard infinite. Now, the minimum would be the lowest point on the graph. Is there a lowest point on this graph? No, because it keeps going down forever and ever and ever. So you're on the right track with infinite. Here's how I'd like you to write this, though. Just say no min. Just write no min. There is no min. No limit. Yeah, that's good. All right. So, folks, that's where we're going to leave it for today. We don't have a whole lot of time to get started on the assignment, but I want to get you started on the first problem from the assignment. So if you could get out whatever you're going to do your assignment on, and I'm just going to write this down for you because people have been confused about this today.